Hello everybody and welcome back to Math. How are you all doing today? Let me know in the comments. But today we're going to be doing something a little bit different. This isn't usually covered in a standard pre-algebra or even an algebra curriculum, but this is usually something that's talked about in a class such as modern algebra or linear algebra, and these are concepts that are usually talked about in a university setting. So you might be thinking, okay, why are we even talking about this right now? But the reason is that I think these concepts, A, are pretty simple. It's just giving some names to some ideas that we already know. And B, I think by talking about it, that's going to keep this a little bit more at the forefront of our minds, which is going to be useful for the upcoming videos. So I think this is something that's worthwhile for us doing, even though it's not usually covered until a much later course. But don't let that intimidate you. It's honestly probably easier than a lot of the stuff we've already been doing. So with that being said, let's jump into it.
Inverse operations.
So in the dividing by a fraction video, we've actually already kind of talked about what I want to focus on today, and that's just the idea of inverse operations. And really what the concept there is that plus is the opposite of minus, and multiply is the opposite of divide, right? We talked about how if I have 3, and if I add, let's say, 7 to it, I get 10. But if I subtract 7 from it, I get back to 3. So in a sense, we see that this addition by 7 is undone, or it's the opposite of this subtraction by 7. So a more fancy way that we can say this is that addition is the inverse operation of subtraction. Right? If I subtract 7, the way to undo that or do the opposite of it is to add 7. And similarly, we can say that subtraction is the inverse operation of addition. And we saw another perspective on this that we've been kind of talking about and using since the very first episodes of this course, where you can think about addition as it's sliding your number line to the right? But subtraction is sliding the number line to the left. And so if I slide the number line, let's say 3 to the right, but if I slide it 3 to the left, so I'm subtracting now, that just takes me back to where I started, right? So they undo each other, right? So this was kind of another perspective on, they're kind of the same thing, right? They're both slides of the number line, just in opposite directions. So hopefully that gives you a good idea as to why we say addition and subtraction are inverse operations of each other. We can do the exact same thing with multiplication and division. And this was kind of the big point that we had in the last video. So we could do 5 times 3 to get to 15. And what can we do to go from 15 to 5? Well, we can divide by 3, right? And so we see that division by 3 takes us back to 5. So division kind of undoes multiplication and vice versa, right? Let's say we started with 15, divided by 3 first, we got to 5. And then afterwards we multiplied by 3. We get back to the original 15 at where we started. So we have both multiplication is the inverse operation of division and division is the inverse operation of multiplication. So another way we saw this with the number lines is that multiplication was a stretching of the number line, right? And division was a compression. So both of these were essentially something that changed the distance between numbers on the number line, except multiplication made it go out, right? It made the distance larger, and division compressed it. It made the distance smaller. So again, they're the same type of operation, just doing it in the opposite way. So again, that's another reason why they are inverses of each other. So we have a good idea as to what an inverse operation means, but if I were to explicitly write it out, I might write it as something like this. The inverse of an operation is another operation that undoes it. So the inverse of addition was subtraction because subtraction undoes addition. The inverse of subtraction was addition because addition undoes subtraction, and so on and so forth. Another kind of operation that we thought about was adding a minus to something, right? We thought of a minus as basically something that flipped our number line, right? So if we took 3 and we applied a minus to it, that gave us minus 3. What do you think the inverse of applying a negative would be? It would actually be just applying another negative, right? Because we know that negative 3 got us back to positive 3, right? Because a negative just flips which side of the 0 you're on. It changes your direction. So since there's only 2 directions to go, a direction change from the negative takes us back to the positive. So we actually get here that applying a negative is actually an inverse of itself. Now, one way we could actually view this is that to go from 3 to minus 3, another way I can think about applying a negative is by multiplying by negative 1, right? And so multiplying by negative 1, that takes me to negative 3. And now if I want to use the idea of doing the opposite, well, what's the opposite of multiplying by negative 1? I can think of that as dividing by negative 1. But since multiplying and dividing by negative 1, neither of them change how large the number is, they only change the sign, then this is effectively doing the same thing as this, but it's just another perspective that we can apply to it that makes use of multiplication's inverse, namely division, rather than kind of introducing a new operation and saying that its inverse is itself. So you can kind of think about this in both ways. All right, so now that we have the idea of inverse operations under our belt, what I want to do now is kind of change how we're going to look at these. And instead of thinking of them as addition is the opposite of subtraction, well, I want to actually think about what number we're adding and what number we're subtracting, and how we can kind of include the operation inside of the number. So let me show you what I mean.
Additive inverses.
All right, so if I did something like 5 minus 3, we know that means I start at 5 and then I move 3 back, or I'm taking away 3 from it, right? But we also saw that this could more complexly be expressed as 5 plus negative 3, right? We saw that this was essentially just addition, but since there's a negative here, we're moving in the opposite direction as we normally do. And since the opposite direction of regular addition is subtraction, we saw that these two were the same thing. But one kind of value of this that we're actually going to be talking about today is that we can express both addition and subtraction through addition. Obviously, addition can be expressed as addition because, well, 5 plus 3 is just 5 plus 3. That's nothing new. But with subtraction being able to be expressed as addition, we get that both addition and subtraction, which we know are kind of two sides of the same coin, right? They're both kind of these number line shiftings, just in opposite direction. They can be expressed both with addition. So what we can start doing with this is we can essentially think of addition is a number line shift. And we're not really thinking of subtraction as a number line shift anymore. We're just thinking about, okay, addition is the number line shift. That's what this means. But now what this means is that when we have 5 plus 3, that means we're shifting 3 to the right. But if we do 5 plus minus 3, so again, we know that's subtraction, but if we're viewing it as kind of an addition here, then the addition tells us it's a shift. And we're still moving 3, but now we're moving 3 to the left. So kind of encoded in this now is that this addition is actually what tells us to do the shift. Well, the reason this is useful is instead of letting the operation tell us we're moving to the left, we're now letting the number tell us we're moving to the left or to the right. Right? Before it was plus told us to move to the right, minus told us to move to the left. Now the onus is entirely on the number. If we're adding a positive number, that's moving it to the right. If we're adding a negative number, that's moving it to the left. So now that we kind of have maybe a little bit of a weird perspective on this, we can actually give a name to this number here. So minus 3, we say, is the additive inverse of positive 3. All right, so minus 3 is the additive inverse of positive 3. Well, what does that mean? Well, what it means is that both of these are a shift by 3 when we think of them in the additive sense, right? If we add 3, that's a shift by 3 to the right. If we add negative 3, that's a shift by 3 to the left, right? So since we're thinking of them in the additive sense, that's basically saying we're thinking about these as like shifts, right? So we're thinking of these numbers as shifts. But they're just doing it in the opposite directions as each other, right? Negative 3 will be a shift to the left when we add it, and positive 3 will be a shift to the right when we add it, right? So these are going to be things that undo each other, right? Because again, we know that if we add negative 3, that's the same as subtracting 3, and if we add positive 3, that's the same as adding 3, right? So those undo each other, but now we're not thinking of the operation as what's undoing each other, we're thinking of the number as what undoes each other. So let's do another example. What is the additive inverse of 5? All right, well, again, it's an additive inverse. So we're thinking about 5 as having an action that shifts, right? That's the additive piece. So since it's positive 5, that means that it's going to be a shift of 5 to the right. However, what's going to be the opposite of that? Well, that's going to be a shift of 5 to the left, and that's going to be encoded with minus 5. So we've kind of always known that 5 and negative 5, or 3 and negative 3, were kind of opposites of each other. But this is making it a little more explicit as to what we mean by them being opposites of each other. They're opposites of each other in the sense that they both are shifts, but in different directions. And that's when we think about them in this additive sense, or in this shift sense. And let's do one more example. So what if I said, what is the additive inverse of negative 23? All right, so negative 23 thought of as an additive thing, right? That's basically a shift 23 to the left because it's negative. So what's the opposite of that? Well, it's going to be a shift 23 to the right, right? So that is going to be 23, just positive 23, right? So again, we kind of know that the opposite of negative 23 is positive 23, but we're explicitly saying how it's the opposite, right? It's the opposite in terms of the direction it goes when we're thinking of it as a shift or as something that we're adding. And the reason this is important to clarify is because we can also think of the opposite of these numbers if they're being applied through multiplication or through division. So let's go on to that idea now.
Multiplicative inverses.
So I could have something like 10 divided by 2, but we also know that I can express this as multiplication because we know that 2 is 2 over 1. And so we saw in the last video that when we divide by fractions, that's the same as multiplying by the reciprocal, right? So this is going to be the same as multiplying it by a half. All right. And so we kind of see that we can express division always through multiplication. So kind of how we could always express subtraction through addition, we're going to be expressing division always through multiplication here. And what this is going to do is it's going to basically allow us to think of multiplication as being kind of the stretch or the compressing operation, but based on what number we have here is going to actually determine if we have a stretch or compress. Just like before, based on if the number was negative or positive, determined how we would move it to the left or to the right. For example, if we have 10 times 2, we can think of that as a stretch out by 2, right? So we can think of a stretch out like this. And then if we have 10 divided by 2, well, that's the same thing as 10 times a half. And so we can think of that as almost like a stretch in by 2 or a compression by 2, right? But let's call it a stretch in by 2. Because what we're going to do is we're going to kind of think of multiplication here as kind of being this stretch part. But then depending on this number here, it's going to be either a stretch out or a stretch in or a compression, right? And the way we determine if it's a stretch out or a stretch in, it's not going to be determined by a minus sign this time. It's going to be determined by the size of the number. So if the number is bigger than 1, right? So 2 is bigger than 1, then it's going to be a stretch out, right? Because we're basically taking those distances and we're making them go bigger than 1. Whereas if the number is less than 1, right? So a half is smaller than 1, then we're going to be taking those distances, and those distances now are going to be basically smaller than what they were before, right? A half is smaller than 1. So that means a distance that was normally 1 now becomes a distance of a half. So now what we're doing is we're taking division and we're expressing it as multiplication because we know that division is just going to be some sort of stretch in, or multiplication is going to be some sort of stretch out. But they're both a type of stretch, just like with addition and subtraction, they were both a type of shifting. So we could then say something like this. 1/2 is the multiplicative inverse of 2. So again, in this sense, a half is kind of like the opposite of 2, but now they're opposites in the sense that of how they're actually stretching or compressing the number line. And so that's where this multiplicative part comes in, because this tells us basically how we're considering them as inverses of each other. So what's the multiplicative inverse of 5? So we're thinking about 5 as being kind of something that stretches the number line by 5 because we're thinking about it in the multiplicative sense, right? We're applying it through multiplication. Whereas before, when we thought of 5 in the additive sense, we thought about it when we were applying addition. So its inverse was -5. But here, what's the opposite of multiplication by 5? Well, we know it's division by 5, but if we want to think about it in terms of kind of like purely these stretches, we're still going to say it's going to be multiplication by something, but specifically, it's going to be multiplication by 1/5, right? Because multiplication by a fifth is the same as division by 5, right? So this is going to be basically stretching the number line in or compressing it by 5. All right, so what if I said, what's the multiplicative inverse of 2/3? Well, we want to basically see, okay, what does the opposite of multiplication by 2/3? And we actually saw in the last video that was equivalent to us finding the reciprocal, right? Because if we divide by 2/3, that's going to be multiplying by 3/2. So actually the reciprocal is the same as the multiplicative inverse, just another name for it. Now, in this situation, 2/3, that is smaller than 1, right? Right, the numerator is smaller than the denominator. So when we think about 2/3 in the multiplicative sense, that's actually going to be a stretch in or a compression because it's smaller than 1. Whereas what we get with the inverse, this 3/2, that's going to be a stretch out because, well, it is larger than 1, right? So again, we can kind of go in both directions where we either think about the stretching in first and then doing the opposite to get the stretch out, or we could think about the stretch out first and then do the opposite to get the stretch in. Because they're inverses of each other, it's just this constant cycle of stretch out, stretch in, stretch out, stretch in, right? Multiply by 2, multiply by half. Multiply by 2, multiply by half. Multiply by 2, divide by half, right? Same thing. Okay, so hopefully this all gives you a good idea as to kind of what I mean by a multiplicative inverse or an additive inverse. It's just how we can kind of think about the opposite of a number with respect to the operation that we're applying with them. Whether it's addition, which we're grouping subtraction with by adding that additive inverse, or if we're thinking about it as multiplication, where we have some sort of stretch by 2 and we're lumping in division in there by thinking about it as a stretch by basically the reciprocal or by the multiplicative inverse. So this is just kind of another maybe more complicated perspective on the things we've already been doing, but we've shifted the power of kind of how we're doing the stretch or how we're doing the shift from the operation of addition and subtraction to the number itself. Now that we have all this in mind, let's go on to kind of one last topic here, which is going to tie all this in very nicely together to two of the numbers you're probably the most comfortable with, 1 and 0.
Identity elements.
So if I ask you, what is the additive inverse of 0, what would you say? Well, let's think about what 0 does as addition, right? If we're considering 0 through the addition operation, well, it does nothing, right? Anything plus 0 is nothing. We actually saw in some examples that if we added 0 to the number line, that just kept the number line still. It didn't do any shifting, right? So 0 is no shifting. So how do we undo that? Well, we don't really need to undo that, right? If we haven't done anything, then to take us back to where we started, we don't need to do anything again, right? So that would imply that the additive inverse of 0 should be 0 itself. Another reason for this is when we did the additive inverse, we just took a negative, right? But we know that negative 0 is just 0, right? 0 doesn't really have a direction because direction is all measured relative to 0. So because of this, the additive inverse of 0, that's 0. So this is kind of an interesting situation where 0 is the additive inverse of itself. And it's the only number with that property. Right? Additive inverse of 1 was negative 1. Additive inverse of 45 is negative 45. Right? Anything that's not 0 has a sign, it has a direction to it. And the additive inverse undoes that direction, right? But here, this is kind of like a directionless thing, so there's nothing to undo. So it in itself is its own inverse. And there's a very similar thing with multiplication. So what if I ask you now, what is the multiplicative inverse of 1? So what does 1 do when we multiply, when we consider it as a multiplication? Well, it does nothing, right? Because what a number does when we multiply by it is it tells us basically how much to stretch the number line out by, right? But by default, the distance between kind of two of our ticks, right, the distance between 1 and 2 or the distance between 4 and 5, that by default is 1, right? So kind of when we multiply by 1, that does nothing, right? 1 does no stretching or compression. And if we think about the reciprocal of 1, right? So if I do the reciprocal of 1, well, 1 is the same thing as 1 over 1. And the reciprocal of 1 over 1, well, that is just 1 over 1 again, right? So it equals its own reciprocal. Which means that multiplying by 1 is the same as dividing by 1 effectively, right? And so the multiplicative inverse of 1, right? The opposite of 1 through multiplication is still 1, right? Because dividing by 1 does the same thing. Both of those don't affect the number line. Neither of them really causes a stretch or a compression. So we then say that 1 is the multiplicative inverse of itself. So both of these have kind of a unique flavor of 0 being somehow like this unmoved thing when it comes to finding its additive inverse, and 1 is this unmoved thing when it comes to finding its inverse through the multiplication sense, right? And so what we say is we call these identities. So we say that 0 is the additive identity. That's because it's its own inverse, essentially. And we say that 1 is the multiplicative identity. So right off the bat, we can kind of see that 0 and 1 kind of have the same role, just 0 has the role for addition and 1 has the role for multiplication. And we're going to actually list a few properties here to really emphasize that 0 and 1 kind of do the same thing, just with regard to their own operation. So one thing we know that's kind of nice with 0 is that when we take any number and we add it to 0, we just get the number back, right? 3 plus 0 is 3. 5 plus 0 is 5, right? So anything plus 0 is itself. Similarly with 1, if I take any number and I multiply it by 1, I just get that number back, right? 3 times 1 is 3, 5 times 1 is 5. So we can say then that anything times 1 is itself. So maybe you're starting to get an idea for why we call these both identities, right? 0 is the additive identity because when we consider addition, it kind of keeps things the same. And 1 is the multiplicative identity because when we consider multiplication, it keeps things the same. We also know that the additive inverse of 0 is 0. And we know that the multiplicative inverse of 1 is 1. There's kind of one other property that these both have in common. Let's consider something like 5 plus negative 5. So I'm taking 5 and I'm adding it to its additive inverse, right? And that gives me, well, 5 plus negative 5, that's 5 minus 5. That's 0, right? Or let's do negative 7. What's the additive inverse of negative 7? It's just positive 7, right? Those are like the opposites of each other with respect to this addition. And when we add them together, we get 0. So we kind of see that anything plus its additive inverse gives us this additive identity. It gives us a 0, right? Similarly with multiplication, if I do 5 times a fifth, right, so I'm taking 5 and I'm multiplying it by its reciprocal, which again was how we found the multiplicative identity, that's going to be 1. Or let's say I do 2 over 7 and I multiply it by its reciprocal, or its multiplicative identity, that's times 7 over 2. And if we multiply that out, we get 14 in the numerator, 14 in the denominator, which simplifies to 1 yet again. So anything multiplied by its multiplicative inverse is going to be the multiplicative identity. Right, so additive identity gives us 0, multiplicative identity is 1. So we see that there's just these parallels all the way through with kind of how 0 functions for addition and how 1 functions for multiplication.
Concluding thoughts.
So that's going to do it for me today. Hopefully you have a more in-depth understanding about what really a negative number is, or what really the reciprocal is. There's actually kind of this higher structure that's going on here where addition and multiplication have a lot of the same kind of patterns to them, where we can think about numbers as not really things that addition and subtraction or multiplication and division do things to, but rather we can kind of think of numbers as being the instructions for how to add, right? We could think of addition by 3 as how to add or how to shift by 3, or we could think of addition by negative 3 as how to add or shift by 3, but in the opposite direction. Same thing with multiplication. We can think of kind of a number as being an instruction about how to multiply, and the reciprocal of the number is the instruction on how to stretch, but in kind of the opposite direction. And then we saw that there were identities for both addition and multiplication. And these were just numbers we're very familiar with, 0 and 1. And they both have these very nice and very kind of parallel properties where anything plus 0 is itself, anything times 1 is itself. The inverse of 0 is 0 when we think about it in the additive sense, and the inverse of 1 is 1 when we think about it in the multiplicative sense. Furthermore, when we add numbers with their additive identity, we get 0, and when we multiply numbers with their multiplicative identity, we get 1. So hopefully you can kind of see these nice patterns going on. And this is all part of a large area of math called modern algebra, where it really goes into a lot of depth into actually kind of looking at the larger structure of these things. And it's a really fascinating course. Hopefully I'll cover it one day. It's a long, long ways away. But again, the big reason for me bringing this up is A, for you to just kind of get some practice with understanding some things that you already know, but in kind of this more structured and this different context. Because again, perspective is everything in mathematics. The more perspective you have, the more versatile you are. But another big reason for bringing this up is in the future videos, we're going to be talking about kind of addition and subtraction and multiplication and division and how those can kind of be blended into each other, and the order in which we do them doesn't really matter. And one way we can think about why that is because they're pretty much the same thing, right? And I hope I really drove that home in this video, where addition and subtraction are the same thing. And similarly, multiplication and division are the same thing, where they're both a stretch, but we just put all the power on the number to tell us if it was going to be a stretch inwards or a stretch outwards, depending on if it was bigger than or smaller than 1. All right, so let me know if you have any questions, and I hope you enjoyed the video. But until the next one, you have a good one, you stay groovy, and I'll see you then.
F.O.A. Maths.